All right, so let's talk about really something very complicated like acetylcholinesterase. I'm not showing you this because I expect you to memorize this. I just wanted to try to jump into very complicated modes. You can see how really complex all this stuff is when we talk about it. So again, acetylcholinesterase is a protein. It breaks down the neurotransmitter acetylcholine or acetylcholine, depending on who you talk to. The acetylcholinesterase is going to cleave the acetylcholine into choline and acetate by hydrolyzing it. That means it requires a water group or a water molecule to separate that. So there's my acetylcholine. It's a neurotransmitter. Notice my nitrogen's making 4 bonds here, so that's where that positive charge comes from. And there's the acetate, the acetic acid right there, the carboxylic acid. And we're going to split that in half using acetylcholinesterase. Acetylcholine is a neurotransmitter that neurons use to communicate with muscles. It's used in the neuromuscular junction. We'll talk all about that later. And remember, acetylcholinesterase is going to take acetylcholine and break it down into acetate and choline. And we used to leave it like that, but I just wanted you to understand chains of amino acids and how they form machines. So there's my acetylcholine, and it's going to get divided. It's going to get broken in half into choline. There's choline. When you talk about lecithin and eggs and choline, there it is right there. Okay? And there's acetate, acetic acid. All right. So again, I'm going to take the acetylcholine, I'm going to break it in half, but I need an oxygen to do that. And so there's that little extra oxygen right there on the acetate. Okay? Where does that come from? It's going to come from serine. And so when they talk about acetylcholinesterase being a serine protease, that means that serine is going to be the knife edge. This big, huge glob of protein is going to pull the acetylcholine in and put it in a perfect little place. And right where the acetylcholine needs to be broken in half is this little knife edge. And that knife edge is that oxygen on a serine. And so that's where the word serine protease, it's going to break down protein bonds, it can break down peptide bonds, and it seems like a peptide bond in acetylcholine to make things confusing. All right, so there's my acetylcholine again. The choline is in blue, the acetate is in red. And there's my acetylcholinesterase. It's the protein that breaks down the neurotransmitter acetylcholine. And in this huge chain of amino acids, right here in a very special place is serine and its oxygen group, its hydroxide group. I don't have the hydrogen drawn there, but it sits right here like the knife edge. And so that's the reactive part of the enzyme, the serine. Notice that little orange oxygen. Well, also on the acetylcholinesterase is this little bowl, and it's made of aromatic rings, and they sit together in a bowl. They create this negative charge, and that negative charge attracts the positive charge on the quaternary nitrogen. And so when it pulls it in, it sets it right in the perfect place so that serine can break apart the molecule. And once the serine loses that oxygen group, notice there's a change in the little bowl to release the nitrogen from it. And so now I have my choline and my acetate. And then a water molecule will come by. It's already right there, and the serine will take it and recharge and ready to do it again and again and again and again and again and again, over and over and over and over again. All right? This is how one protein works. Incredibly complicated. So when we talk about proteins, you can understand that this machinery is very complicated. A single acetylcholinesterase, that's what that ACE is, acetylcholinesterase, this big enzyme, can degrade 25,000 molecules of acetylcholine per second and not destroy itself. It just sits there and recycles itself. Okay? So this is how chemical reactions occur in the body. Very similar to this.